Hello and welcome to Physics Basket. So the topic that we are going to discuss today on class 11 vector problems 5, wherein we are going to discuss on perpendicular and coplanar vectors. So let us get started.
Let's get started with the next question. It says that a vector is perpendicular to A 3i minus 2j plus 2k and B minus 4i plus 2j minus nk. And this perpendicular vector is I plus j by 2 minus k. So it says that there is a vector which is perpendicular to these two vectors. Given vectors is this. So we need to find the value of n in this case. So we know that when we do a cross product of two vectors, then we get a vector which is perpendicular. We get a vector which has some magnitude and it is perpendicular to the plane containing both the vectors which we do cross product. So if we do A cross B, so we get something like A B sine theta into n cap. What is this n cap? N cap is nothing but the unit vector which is perpendicular to the plane containing A and B, and whereas A B sine theta signifies the magnitude of that particular vector. So if we somehow find the cross product of this vector and try to correlate the cross product outcome with these value, then probably we will be able to find the value of n. So let's try that way. So let's do A cross B. Then in the determinant form, it will be I, J, K, and then we have P minus 2, 2, minus 4, 2, and minus, right? So let's find this out. And this gives us I cap into 2n minus 4, right? This and this we did. And j, so we'll say minus j into minus 3n plus 8. This, and this minus 3n plus 8. Okay. And plus k into what we get 6 minus 8. So this we get 2n minus 4 I cap plus 3n minus 8 j cap minus 2k. Okay. Now what is the so this is basically the vector which will be perpendicular to the plane containing A and B. Now this, what does it signify? This signifies the vector, and it may have a magnitude which will be which can be a multiple of this particular vector, right? So I have the given vector already, which is perpendicular to the plane containing both of this is I plus j by 2 minus k. So let us correlate this. So if I make half, so example, these two are the vectors given, right? A and B. And the third vector C, which is a cross product of this, comes along like this, and which is this one. Now I have another vector which is basically this, right? This vector, which may not have the same magnitude as C, which is cross product of A and B, but it is in the same direction of C because it is also perpendicular. So if I somehow correlate these two vectors, then I'll be able to find the value of n. So if you see minus k, here it is 2k. So let me just make half of it because its magnitude may be half of it. So I will say n minus 2. So I will say c by 2, right? C by 2. C is what? C is a cross B. C equal to a cross b. Then I'm making c by 2 will be n minus 2 into I cap plus c by 2 n minus 4 into j cap minus k. Now if I try to correlate these two, then I can say this and this. So n minus 2 is equal to what? 1. And p by 2 n minus 4 is equal to 1 by 2. So from here, from the first equation, let's try to find out what becomes. So n is equal to 3. And is it correct or not? We can just cross verify. So put this n3 here. So it is basically 3 into 3, 9 by 2 minus 4, which is nothing but half again, right? So this means that this is correct. So the answer of this particular equation is n equal to 3. So which will satisfy the value that the vector which is perpendicular to this 2 will be I plus j by 2 minus k when the value of n is equal to 3. That's our answer. So let us have the next question. It says that find the value of x so that the three vectors 2i plus 3j plus 2k and xi plus 18j plus k and minus I plus 2j plus 3k are coplanar. Okay. So okay. So for the vectors to be coplanar, basically, let us say these are the three vectors A equal to 2i plus 3j minus 2k, and then we have B, which is equal to xi plus 18j plus k, and the third vector, let us call it as C, which is equal to minus I plus 2j plus 3k. And for these three vectors to be coplanar, we can say that the scalar triple product is equal to 0, which means that A cross P dot C is equal to 0. And when does it happen? Basically, A cross B will be a vector which will be perpendicular to the plane containing A and B, right? And if the dot product of this vector, basically A cross B with C, the third vector, is 0, means that the resultant of A cross B is basically perpendicular to C, right? Which clearly means that A, B, and C are coplanar, right? Okay. So let us do this scalar triple product. So for scalar triple product, it is basically this determinant that has to be 0, which is, let us say, 2, 3 from the first vector, 2, 3, and minus 2. The second vector is containing x as the coefficient here, and then 18, and then we have 1 and minus 1, 2, and 3. And this is equal to 0 for us because they are coplanar, right? So which means that, let's say, do this 18 into 2 into what is 18? 3. 54 minus 2, right? And then minus 3 into 3x plus 1, right? Plus 1 minus 2 into, okay, I have taken this one as minus 3 and then I have multiplied like this. Minus 3 into 3x, this one, yeah. And in this case, it's directly minus 2 into in this direction. So which is 2x plus 18, right? and this is equal to 0. So what we get it here is, it is already 54. Is it 54? Yeah. So yeah. So 52 into 2. This is 104 minus 9x minus 3. Here it is minus 4x minus 36 is equal to 0. And we get it 104, 13, and so this gives us 65. This is 65 minus 13x, right? So 65 equal to 13x, or we get x equal to 5. So this is the condition wherein we get the t vectors to be coplanar.